A roaring shredder rips the metal into palm-sized flakes. These chips ride a conveyor through a rotating washer, where jets of hot caustic water strip off paint. The aluminium liquefies into a silver pool. Operators skim off floating dross, those dark oxides that would weaken the casting. Molten metal flows through a ceramic filter and into sand-coated dies shaped like a kettle shell. Within seconds, the outer skin solidifies. After 5 minutes, the whole casting is cool enough to lift. Robotic arms crack open the molds and transfer each rough kettle to a trimming press. Excess flash is sliced away. Then the body spins on a lathe where carbide bits shave the rim perfectly round. Separate spouts and handles are die-cast from the same recycled melt. A TIG welder fuses them to the body. Clean joints, no leaks. Quick dip in water checks for pinholes. Kettles tumble with ceramic media, then fly against buffing wheels for a mirror polish. Finally, an anodizing bath seals the shine and resists kitchen stains. Inspectors tap each kettle for a clear ring, screw on the whistle, and slip it into a recycled cardboard box, ready for the next cup of tea. A high-speed press punches hundreds of perfectly shaped laminations every minute. These thin steel discs will stack into the stator and rotor cores that power the fan. Precision here means a quiet, energy-efficient motor. Robotic arms wind enamel-coated copper wire around each stator slot with millimeter accuracy. Automatic varnish dipping then locks the windings in place, improving insulation and lifespan. Aluminum end rings are die-cast onto the rotor stack, creating a squirrel cage rotor. The rotor is spun on a dynamic balancer. Tiny metal chips are shaved off until vibration disappears, ensuring whisper-smooth operation. Fan blades start as flat aluminum strips. Hydraulic presses curve, taper, and punch mounting holes in one motion. A quick pass through a deburring drum removes sharp edges. Both blades and motor housings enter an electrostatic booth where dry powder paint clings like magic. Technicians fit the rotor into the stator, add silent running ball bearings, and detach the decorative housing. Balance blades are bolted on, followed by the down rod and canopy. Every bolt is torque checked for safety. Each completed fan spins on a test rig for 30 minutes. Sensors verify speed, current draw, and noise level. Only units that pass 100% of checks receive the factory seal. Ever wondered what turns a flat sheet of steel into the reliable gas stove in your kitchen? The journey starts with large coils of mild steel. Automated lasers slice each coil into flat blanks. Hydraulic presses then stamp those blanks into the familiar top panel, sidewalls, and bottom tray, precision holes already punched for burners and controls. Robotic benders curl and fold the stamped parts, locking strength into every edge. Spot welding arms fuse brackets and supports so the frame can handle years of cooking heat without warping. Next, the raw metal takes a bath. It's degreased, rinsed, and dipped in an anti-rust primer. After drying, an enamel powder coats the parts. Inside a 800 degrees Celsius oven, the powder melts into a glass-hard finish that resists scratches and stains. Meanwhile, brass pellets drop into induction furnaces and melt, the creating rings lined with hundreds of tiny gas ports. CNC machines drill and polish each port so flames spread evenly. Precision-turned brass valves control the gas flow. They're paired with venturi tubes that pull in air for a clean blue flame. Technicians grease the valve stems and snap on heat-resistant knobs. Every stove enters a sealed booth where compressed air checks for microscopic leaks. Passing units ignite on a test line. Inspectors look for a steady blue flame at every setting. Think that rusty bundle of scrap wire is useless? Watch as a recycling workshop transforms. Trucks unload mixed scrap. Magnets lift out the iron wires, leaving copper and plastic behind. Workers strip away any remaining insulation, so only bare steel heads to the line. The wires roll through spinning steel brushes that grind off rust and dirt. Next, a series of roller dies stretch and straighten each strand, erasing kinks and giving the metal uniform tension. To achieve perfect diameter, the cleaned wire is pulled through tapered carbide dies. Lubricant keeps it cool while it shrinks to a smooth, round profile. Automated arms bend each rod into an oval. A flash welding electrode then zaps the open ends together, creating a seamless joint that's stronger than the original wire. A rotating spindle feeds fresh links through the previous ones, forming meter after meter of continuous chain. Verifying every batch meets Tensile standards. Approved coils are wrapped, tagged, and shipped off for construction, farming, and heavy lifting. So, the next time you spot a gleaming iron chain, remember, it might have started life as a forgotten tangle of old wire, reborn through the magic of smart recycling.